Hello, algebra students. We are continuing in chapter 6, and this chapter is all about systems of equations. We are in section 6-3, day 1, and we're going to learn a third way to solve systems of equations. So far, we've solved them by graphing and substitution. Today is the third way. So let's get started here at the beginning. It says, when two linear equations are both in standard form, it may be easier to solve with a method called elimination instead of using substitution. So there are lots of different ways that these can be written. As you have already seen, like with graphing versus substitution, we can write these problems so many different ways. I'm just going to show you one type of problem to begin with, and then we'll build from there. So we're talking about a new strategy called elimination. That's the new thing from today. And we have some basic steps for doing this. So first of all, we need to make sure that the equations are set up so that the like terms are vertically aligned and organized. So what that means is I want my equations to have the x's in line, the y's in line, the equal sign in line, and then the plain number in line. So notice this equation and this equation are together. So I have 5y plus 2, whoops, that should be to an x, is equal to 17. Then I have 6x minus 5y is equal to negative 9. I want to write this in the order to where it will line up. So I'm going to have negative 5y plus 6x is equal to negative 9. So notice the y's are aligned, the pluses are aligned, the x's are aligned, the equals are aligned, and the plain numbers are all aligned. So I have that set up in step 2. After they are all lined up for you, you are going to add the like terms up and down. So after they are all lined up, you add it from top to bottom. So here, I'm adding these two equations. So 2x plus 6x equals 8x. 5x plus negative 5y plus negative 5y is 0. Those cancel out. Is equal to 17 minus 9 is going to be 8. So now I have 8x is equal to x. Once you have that worked out, you can solve for the variable that is remaining in that expression. So I have 8x is equal to 8, so I'm going to divide by 8 on both sides, and I get x is equal to 1. Okay, now this is going to be similar to substitution. I'm going to take this x equals 1 and stick it into one of the original equations. Ideally, you pick an equation that's easier to work with. So pick an equation that doesn't have negatives or has smaller numbers or whatever. So my next step is to substitute that value back in. I'm going to substitute it into this equation, the 2x plus 5y equals 17, which is this top one right here. So this is going to be 2 times 1 plus 5y is equal to 17. That's 2 plus 5y equals 17. Subtract 2 from both sides. 5y equals 15. Divide by 5 on both sides. Y is equal to 3. Okay. Now everything is just like what we've been doing before. We want to write our answer as an ordered pair or a point or a coordinate, however you want to say it. So that's in parentheses my x value, which is 1, comma, my y value, which is 3. Then I want to check my work. There are so many places that we can make mistakes, and I know I make them all the time. So we do want to go back and substitute in our values into both of the equations to make sure that we have the correct solution. So I'm going to put I'm going to replace x with 1, and I'm going to replace y with 3 in both of the equations. So I have 2 times 1 plus 5 times 3 equals 17. And then I have 6 times 1 minus 5 times 3 equals negative 9. Let's check and see if those are true. This is 2 plus 15, which is 17. That works out because 2 plus 15 is 17. This is 6 minus 15 equals negative 9. Yes, negative 9 equals negative 9. It's correct. So I now know my solution works, and I can move on. So the main steps one more time. Get your equations lined up. Add them. Solve, substitute, back in. We're going to do quite a few examples of these so you can see the pattern. All right, so example 1, I have 5x minus 6y is equal to negative 32, and 6y plus 3x is equal to 48. I want to get the variables lined up first. So I'm going to have to rewrite one of these equations. It doesn't matter which one you rewrite. Just make sure that you get the signs correct. I'm going to rewrite the bottom equation. So I'm going to have 5x minus 6y is equal to negative 32. That stays the same for the top. And now I'm just rearranging this so that my x's and y's will line up. So this is 3x plus 6y equals 48. Okay, now I'm going to add these up. 5x plus 3x is 8x. Negative 6y plus 6y cancels, is equal to negative 32 plus 48 is 16. So now I'm at 8x is equal to 16. I'm going to divide by 8 on both sides and get x is equal to 2. Awesome. I have x equals 2, but I can't stop there. I need to keep working and figure out what y is. So I'm going to take this x equals 2, and I'm going to stick it back into this bottom equation. So that's going to be 6y plus 3 times 2 is equal to 48. I replaced the x with the 2 because that's what I solved for it to be. Now let's keep working through this. So I have 6y plus 6 is equal to 48. Subtract 6 from both sides. 6y is equal to 42. That gets me y is equal to 7. So my answer, my final answer is going to be an ordered pair of 2, 7. That's my final answer. But I do want to go ahead and check my work. So I'm going to place the 2 in for the x and the 7 in for the y in each of my equations to make sure they balance. So this is 5 times 2 minus 6 times 7. That should get me negative 32. And this is going to be 6 times 7 minus 3 times 2, which is 48. So this is 10 minus 42. That will get me negative 32, so that one checks out. This is 42 minus, is it minus? No, it's plus. There we go. It's plus 6, which equals 48. 42 plus 6 is 48, so that one works out. I know my answer is correct. Okay, let's keep working through these just to practice. I need to rewrite example A because notice the x is on top of the y, but I need the x to be on top of the x. So it doesn't matter which one you rewrite, you just have to make sure you keep the signs correct. Keep the signs with the correct term. So I'm going to rewrite the bottom one. So this is going to get me 3x plus 4y is equal to negative 3, and negative 3x plus y is equal to negative 12. Okay, add them up vertically now. 3x and negative 3x cancel. 4y plus y is 5y. Negative 3 plus negative 12 is negative 15. Divide by 5 on both sides to isolate the y, and I get y is equal to negative 3. Now that I have y is equal to negative 3, I want to use that to figure out what x must equal. So I'm going to take it and substitute it back into one of these equations. Doesn't matter which one, but try to choose one that might be a little easier. I think the bottom one looks easier, so that's the one I'm going to do. But if you chose the top one, you're not wrong. So I have negative 3 minus 3x is equal to negative 12. I'm going to add 3 to both sides. That gets me negative 3x is equal to negative 9. Divide by negative 3 on both sides. X is equal to positive 3. So now I have my ordered pair of 3, negative 3 for my final answer. But like usual, we should go ahead and check this real fast. So just over to the side, replace the x with the 3 and replace the y with negative 3. So that's going to be 3 times 3 plus 4 times negative 3. That is 9 minus 12. Yes, that works out because 9 minus 12 is in fact negative 3. Let's check the bottom. That gets me negative 3 minus 3 times 3. So that's negative 3 minus 9. Yes, that works out. Okay, we're going to do this again. In this example, my y's are already lined up. So I don't have to rewrite it. It's already lined up for me, so we can go straight into adding. My y's are going to cancel, and negative 3x plus negative 2x gets me negative 5x is equal to 12, and negative 12 is 0. Don't let the 0 throw you off. You're still solving this the same way. Divide by negative 5 on both sides, and I get x is equal to 0. Now I'm going to take this x equals 0, and I'm going to substitute it into the top because it has fewer negatives. That's why I'm doing it. But you can substitute it into either one. So I have negative 3 times 0 plus 2y is equal to 12. Well, negative 3 times 0, that just cancels out. It goes away. And now I have 2y is equal to 12. Divide by 2 on both sides, and y is equal to 6. So my answer should be 0, 6. But of course, we should check that real fast just to make sure. So I'm going to take this 0 and replace the x, and replace this, and take this 6 and replace the y. So I have negative 3 times 0 plus 2 times 6. And then negative 2 times 0 minus 2 times 6. Well, these are just 0, so that's 0 plus 12 equals 12. I believe that does in fact work out. And this is 0 minus 12 equals negative 12. Yes, that works out as well. All right, let's do these next two examples. Remember, this is using a strategy called elimination. So we're trying to eliminate one of the variables in order to solve for the other. Alrighty, in this one, I do not have my x's or my y's lined up, so I need to rewrite it. I am going to rewrite the bottom one. So I have 6y minus 5x is equal to negative 17. And then negative 6y plus 4x is equal to 16. Okay, add them up. 6y and negative 6y cancel. They have been eliminated. Negative 5x and positive 4x is negative x. Negative 17 and positive 16 is negative 1. So if negative x equals negative 1, I can divide by negative 1 on both sides and get x is equal to positive 1. Now that I know what x is, I can use this information to figure out what y is. I'm going to take that number and I'm going to replace it in one of the equations. I'm going to replace it in the bottom one. So this is 4 times 1 minus 6y is equal to 16. Well, 4 times 1 is 4. minus 6y is equal to 16. I'm going to subtract 4 from both sides because I'm trying to isolate the y. That gets me negative 6y is equal to 12. And now to finish isolating the y, I divide by negative 6. We've talked about this quite a bit. Oftentimes, division is one of your very last steps when solving equations. This gets me y is equal to negative 2. So now my solution is 1, negative 2. We do have one more example of this style that I want to work out with you guys. So once again, a system of equations. A system of equations is 2 equations in one problem. And this is the third way or third strategy we're talking about, which is elimination. In this problem, my variables are already lined up. The x's are on top of the x's, the y's are on top of the y's, and so on. So I can automatically add these. When I add them, negative 3x plus x is negative 2x, positive 2y and negative 2y eliminate each other, and negative 15 plus 5 is negative 10. Now I want to isolate the x. Sometimes people say to add 2. You do not add 2 here. You're going to divide by negative 2 because when a number is next to a letter, it means multiplication. And to get rid of multiplication, we divide. So this is going to get me x is equal to positive 5. I'm going to take this x equals positive 5 and substitute it back up here into this bottom equation. So this is 5 minus 2y is equal to 5. I'm going to subtract 5 from both sides, and that gets me negative 2y is equal to 0. That's okay. Don't let something equal 0 throw you off. I've noticed that's been happening to some people. Divide by negative 2 on both sides, and I get y is equal to 0. So my ordered pair, or my point, or my coordinate, needs to be written in parentheses with a comma in between them. So it's going to be parentheses 5, 0. And that is my solution to part D in this example. All right, so these examples were where the equations automatically added up and then eliminated a certain variable. There is another type of example that I'm going to go through with you here quickly where you have to adjust the equation a little bit. So let me make sure there we go. So when the coefficients are the same but not additive inverses, you should multiply one of the equations by negative 1. For example, notice in this problem, I have 2x and 4x, y, and then negative 8 and negative 18. All of them line up, which is great. But if I were to add these up, I would get 6x and 2y. I don't want to get 2y, I want the y's to cancel. To get them to cancel, they need to be opposites of each other. So I'm just going to take the bottom one and multiply it by negative 1 all the way across. And I'm allowed to do this because whatever you do to one side of the equation, you just have to do to the other. So this is going to be 2x plus y is equal to negative 8. And now I rewrite the bottom, which is negative 4x minus y, which is equal to 18. Add them up. My y's now are eliminated. And I get negative 2x is equal to 10. Divide by negative 2 on both sides. X is equal to negative 5. Now that I know that x is equal to negative 5, I can take this value, plug it back in for x to figure out what y is. Remember, in a system of equations, we have 2 variables, so we need to solve for both variables. So I'm going to have 2 times negative 5 plus y, which is equal to negative 8. This is negative 10 plus y is equal to negative 8. Add 10 to both sides, and I have y is equal to 2. So now my solution is negative 5, comma 2. And we can give this a quick check to make sure that we are correct with our calculation. So let's do that. I'm going to take this negative 5 and replace the x with it. I'm going to take this 2 and replace the y with that. So it's going to be 2 times negative 5 plus 2 is equal to negative 8. And then we have 4 times negative 5 plus 2, which is negative 18. This is negative 10 plus 2 equals negative 8. That works out. And this is negative 20 plus 2, and that works out as well. So I now know my solution is correct. Let's do a couple more of these. Notice the variables are already lined up, but the negative 3y and the negative 3y match. So I need to multiply one of the equations by negative 1 to make them additive inverses. I would strategically do the bottom one because the bottom one has all negatives. So if I were to multiply it by negative 1, it would turn them all to positive. So I'm going to multiply by negative 1, and I have 4x minus 3y is equal to 2. And then I have 6x plus 3y is equal to 18. Now I'm ready to add them up. 4x plus 6x is 10x. Negative 3y and positive 3y are eliminated, and this is going to equal 20. Go ahead and solve this problem the rest of the way, so divide by 10 on both sides, and I get x is equal to 2. This x equals 2 can then be stuck back into this top equation, because not only do I need x, I also need to know what y is. So this is 4 times 2 minus 3y is equal to 2. 4 times 2 is 8, so I have 8 minus 3y is equal to 2. I'm going to subtract 8 from both sides because I'm trying to isolate this y. So now I'm at negative 3y is equal to negative 6. Divide by negative 3 on both sides, and I get y is equal to positive 2. So my coordinates should be 2, 2. We're just continuing this practice in the next examples. In the next examples, I have 3x plus 2y equals 17, and 2x plus 2y equals 14. Notice how the 2y and the 2y are the same numbers, but I need them to be additive inverses of each other. So I'm just going to multiply the bottom equation by negative 1. And this is going to get me 3x plus 2y equals 17. And then negative 2x minus 2y equals negative 14. Now that this 2y and negative 2y are opposites of each other, I'm going to be able to eliminate them. So 3x and negative 2x just gets me x. Those cancel, and that's equal to 3. X is already isolated. I'm moving on to figure out what y is. I'm going to take this x equals 3 and stick it back into this top equation. So this is 3 times 3 plus 2y, which is 17. 3 times 3 is 9, so I have 9 plus 2y is equal to 17. Subtract 9 from both sides, 2y is equal to 8. Divide by 2 on both sides, y is equal to 4. So my solution is going to be 3, 4. We'll just do one more problem because we are beginning to run, this video is starting to get long. So let's just do example C, and then we will call it a day. In example C, the x's are lined up and the y's are lined up, the equals are lined up, and the plain numbers are lined up. But the x's are exactly the same. I want to make them additive inverses. So I'm going to multiply this bottom equation by negative 1, and that gets me x minus y is equal to 2, And then the bottom is going to become negative x plus 3y is equal to negative 2. Okay, now I can add them up. X plus negative x, they eliminate each other. Negative y plus 3y is 2y. And then 2 and negative 2 become 0. I'm going to divide by 2 on both sides, and that gets me y is equal to 0. Now I'm going to take this y equals 0, stick it back up here for y. So this is x minus 0 equals 2. Well, that must mean that x equals 2. So my final solution is going to be written as an ordered pair, or 2, 0. And there you have it. This is the third and final strategy that we're going to talk about. It's called elimination, and we will be practicing for a couple days. So if you're still rocky with it, that's okay. But I hope you have a good night, and I'll see you later.